In this video, we're going to dig underneath the surface of what the for loop does and what iteration in general does. It's not about learning how to use the for loop. I'll assume you know that very well. It's about understanding what happens behind the scenes when we have iterations such as in the for loop. Now, I'm recording this video just after running a nearly 2-hour live workshop, and if you're receiving this video, you are probably at the workshop or you signed up for it, but I'll make it also broadly available. So the purpose of this video is to summarize the session. I do not record these workshops for two reasons. First of all, I want to focus on the discussion and the live aspect of these workshops. There are other recorded things I do. So if you want recorded material like this video, like courses at the Python coding place, the live workshop, I wanted to be live. Also, I did not want to discourage people from asking questions. And sometimes the record button stops people from interacting. That's why I'm recording the summary. So the purpose of this video is primarily as a summary for those who attended the workshop. But it's also going to be a very complete, quick, but complete summary of the whole topic for those who could not attend. So we're talking about iteration. Let's open the REPL. And the idea is, let's assume we have something like a list. Let's start with a boring list. There we go. Did I put extra spaces there? Never mind. There. We can loop through the list, and that we know very well, right? For number in numbers. Now, the first question is print number, say. Print number. What can we iterate through? Whether it's using a for loop or other ways of iteration. And the answer is the data type needs to be an iterable. There's going to be lots of words that sound similar, and they all start with iter, which incidentally is Latin for journey or a path. So it's quite appropriate. We're going through a journey, we're following a path through each item of an object. So something is iterable if I can iterate through it, which means if I can use it in a for loop and other places as well. Lists are iterable. You can try this with strings, with dictionaries, with tuples. They're all iterable. But if I try to do for number in and loop through the integer 10, for example, then this is going to give me an error. Why? Because integer object is not iterable. So that's the first thing. There are certain data types that are iterable, which means Python knows that we can go through them one at a time. This is not just in the for loop. For example, if I use the starred symbol, so I'm unpacking the list numbers within the call for print, that's the same iteration. And at the end of this video, I'll convince you that the iteration happening there is exactly the same as the one happening in the for loop. Python treats them in the same way. Good. The next thing we're going to talk about, so we've got iteration, the process of fetching items one at a time. Iterable, an object I can use in a for loop or in other places where I can iterate. And then we have iterator, and we could create an iterator. So for example, let's create numbers iterator. One way of creating an iterator is calling the built-in iter. And as long as numbers, plural, is iterable, such as a list, a string, a dictionary, etc., then using the iterable as an argument for the built-in iter gives us back an iterator. Keeping up with all these iter words, so an iterator does not contain its data. You can see that it doesn't show me the data. I can't print out the data. What an iterator does is it's showing me where the next item of data is. So the iterator doesn't store its own data. Instead, it's referring to data that's stored somewhere else, in this case in the list numbers. And therefore I can say, can I get the next value of numbers iterator? 2, 3, 4, 5, 6. If I ask for the next value, there are only 2, 3, 4, 5, 6. Now I get a stop iteration, an exception is raised. And in the session, we've seen how, if I go back to the for loop I had before, for number and numbers, we broke this down and we said, what's happening here? So number is a new variable. So Python is creating a new name and it's going to store information in it. So that's the easy part. Numbers, the first thing that the for loop does, and this is true for all iteration processes, is it tries to convert numbers, or to create rather, not convert. Numbers doesn't change. It tries to create an iterator from this object. And therefore, the object has to be iterable, which means we can create an iterator from it. Once it does that, so that would be similar to what we've done there. Create an iterator from the iterable. The for loop then starts calling next, and each time it assigns that value to the variable number. So it's as though I'm saying number equals next number's iterator. Therefore number will be 2, and then 3, and then 4, and then 5, and then 6, until it calls next again, and the stop iteration is raised, and the for loop uses that exception as the signal it needs to stop. And that's what happens in the iteration process. I've gone through this quite quickly, but we're going to make a lot more sense of it by creating our own class. And then we're going to make it iterable. So let me create a class called contact book. And the idea is that we're going to keep, this is going to be a simple class, right? To keep it brief. We're going to create a contact book for our friends or colleagues or whatever it might be. So let's define the init function, and let's say that we're going to name our contact book, for example, my friends, and self.name equals name. And then we're also going to have self.contacts, which is going to be a list. And this is going to be, I'll show you a list of dictionaries. So each dictionary will have first name, last name, email, and it will contain the information for my contact. Let's make sure we can add contact. So let's say add contact and first name, oops, I don't want to do that, last name and email. We're going to only have those 3 parameters. Of course, you can add more if you want, but this is good enough. And what we're going to do is we're going to say, why did the colon disappear there? Take our contacts, which is a list. Since it's a list, we can append, and I'm going to append to it a dictionary, which is going to have first name as a key, and then I'm going to pass whatever argument is passed to first name, last name as another key, and surprise, surprise, we're going to put last name, and finally, no surprise, no prizes for guessing, this is email. So this is going to allow us to create our contacts. So let's try it out and create my friends, and I have let's create contact book, and let's call it my friends. So this is the name of the contact book, right? So that I can separate it from my colleagues or whatever. And what I'm going to do is I'm going to paste the ones I've done in this session just to have to type them. I've called add contact 3 times. With 3 of my friends, I have a peculiar set of friends: Sherlock Holmes, Clark Kent, and Yoda. Yoda doesn't have a surname, right? So we put none there. And those are their emails. Good. Let's check what's happening here. Now, at the moment, there isn't much, right? So if I print my friends, I actually won't see that much because I haven't included the wrapper Thunder method. So often we would then want to include the wrapper there, but I'm not going to do it because I want to focus on the iteration side. So my question is, I've created an object of type contact book, which is this class I've just created. Is this iterable? Let's find out. For friend in my friends, can I print friend? We've seen that if this works, it means my friends is iterable. But if my friends is not iterable, this should raise an error. Contact book object is not iterable. Good. Now, in this session, I talked about get item, but I'm actually going to skip it here. So get item is the dunder get item, dunder underscore get item is a special method we can use to make an object subscriptable. This is when we add the square brackets. For example, if I had my list numbers, number square bracket 0 means fetch the first item. That method makes the class iterable. But that's the old protocol. So I'm going to focus on the new protocol in Python. And by new, I mean it's been there for a long time, but it's newer than the old one. So I'm not going to talk about get item here. Instead, I'm going to talk about the iter dunder method. And this is the method that makes my object iterable. Let me prove it to you. Let me remove this. Let me remind you what the error message is. when I run this, it says contact book object is not iterable. Very clear, right? The object we have is not iterable. Now, remember that error message. Let me create iter, dunder iter. And for now, I'm not going to define it. I'm going to put the ellipsis there, which is a valid placeholder, if you like. Remember this error message? Let me run it again now. Ready? So I still have an error message, but it's a different one. This means that defining iter was enough to make my object technically iterable. The error doesn't say it's not iterable anymore, but we've broken another rule now. The iter_dunder method, you may remember in the console earlier, I don't have it anymore, but I was calling the built-in iter, the one without the underscores. And what that does is whatever argument I pass to iter, Python calls that object's dunder method. So this dunder method is how we can create an iterator from an iterable. Confusing these iter. So the iterable, it's like the list, right? It's the object that we can use in the for loop. We need to be able to create an iterator from it. This lightweight object that doesn't contain the data, but it points to where the data is. This was enough, but this method must return, remember the error message we got? Iter returned a non-iterator of type none type. Why? Because there's no return, therefore a function or a method that has no return statement returns none. And this is not valid because Python is expecting that this dunder method returns an iterator. So one option, we have context, right? That's where our contexts are being stored, and that's a list. And therefore we know that we can convert that list, self.context, into an iterator, or rather create an iterator from it. And that works, but I'm going to do it the long way. And specifically, I'm going to tell you, I want that when I iterate through an object of type contact book, I don't want to see the dictionary with first name Sherlock, last name Holmes. I just want to see first name, last name. So Sherlock Holmes, Clark Kent, Yoda, because Yoda doesn't have a last name. So this doesn't work. Instead, I am going to return a different iterator, and I'm going to call it, I'm going to create this contact book iterator. Now this is going to be a new class which doesn't exist. That's why there's a squiggly red line. And I'll define it in a few seconds. Now, when I create the class, I'm going to, or rather, when I create an instance of this class, which is what I'm doing here, I'm going to pass it some information. And from the iterable, all I want to give it is contexts. So I'm going to pass self.contexts. The iterator only cares about context. It doesn't care about the name of the contact book or any other attributes I might have. So I'm deciding the information I want this iterator to have access to. In this case, it's only the context. Good. Now, contact book iterator doesn't work, so let's define, doesn't exist, so let's define it. Class contact book iterator. Let's initialize it, and we know that it needs one parameter. I'm going to call it contacts, and as always, we link this to the object, to the instance, self.contacts, if I can spell it, contacts equals contacts. Now, an iterator keeps track of which item from the original iterable is next. So the iterator must have a way of knowing where it is in the iterable. Is it about to give you the first item, the second item, the third item, the fourth item? Now, whenever we create an iterator, a reminder, an iterator is created, for example, when you start a for loop. When you start a for loop, Python says, here's an iterable. Let me create an iterator from it, and then I'm going to use that iterator throughout the whole for loop. So I'm going to say, let's give this iterator an attribute called index, and let's set it to 0. And then we're going to be incrementing this. So that's how the iterator knows it's at the beginning. It's going to start from the beginning. We always put 0 there, unless you have a reason where you don't want to start from the beginning. Now, I'm going to do the next bit really quickly because this is a very brief summary. Wait for this. Every iterator is also iterable. Now, we were talking about an iterable like the list or like the contact book object. And we said we want to create an iterator from this iterable. So if we have a list, we can create an iterator from the list, which is not a list, it's a list iterator. And here we're going to, from a contact book, create a contact book iterator. But an iterator can also be used in a for loop. So an iterator can be used directly in a for loop or in any other type of iteration. An example you're probably familiar with is zip. When you call zip, the built-in zip, to zip two or more structures together, that does not return a copy of the data. That returns an iterator. And you can use that in a for loop. You can use whatever comes back from zip because an iterator is iterable. Okay, so how do we make, remember how we made contact book iterable? We had to define an iter_dunder method which returns an iterator. Those are the rules. Therefore, the same applies for this one. It needs to have an iter dunder method, which needs to return an iterator. But contact book is itself an iterator. It's an iterable and an iterator. Therefore, it can return itself. Unlike the iterable, which had to return a different object type because it needs to return an iterator, an iterator, when I'm using it to loop through it, it can return itself. So this is nice and easy, right? When you have an iterator, you pretty much always want an iter_dunder method that returns itself. Now, what makes so far we've made iterator an iterable. We have not made it an iterator yet. For that, I need to define another dunder method, and that's the dunder next. Now, this dunder method is going to be called repeatedly every time. That's what the iteration process does, right? It creates an iterator from an iterable, and then it calls next repeatedly on that iterator. So, what do I want here? I want my contact to be equal to. Now, remember, I want my iteration process to return just first name, last name. So I don't want to return all of my contact. So self.contacts is a reference to the data of my iterable. This is where I have Sherlock Holmes, Clark Kent, and Yoda. So I don't want to return that. I want to return one of those items. This is a list. The first time I want to return one with index 0, and then 1, 2, 3. And that's what the index is doing, right? Now, so far the index is just 0, but we'll figure out how to increment it. Good. Now, I could return contact if I want to return the whole dictionary. For example, that is contact square bracket 0. But I don't want that. I just want the first name and the last name. So instead of returning contact, I'm going to create an f string with first name, last name. And the first name is going to be whatever contact is. And I'm going to fetch its first name. And the last name is from contact index, or rather get the key that corresponds to last name. So this will give me Sherlock Holmes or Clark Kent. We'll get to Yoda in a bit, right? Yoda has a bit of a problem because his last name is none. He doesn't have a last name. Now, this is great. In fact, let's see what happens if I run it now. Can you see? I keep getting Sherlock Holmes in an infinite loop. Why? Because the iterator, or rather the iteration, will keep calling next on the iterator. Now, there are two problems here. Index is always 0, that's why I always get Sherlock Holmes. And also, next will always give me a value because it's always giving me Sherlock Holmes. So there are two things we need to do. The first thing we need to do is, once we've extracted our contact, we can say, take the index and get it ready for the next time. So if it was 0, make it 1. So that next time we need next, index is 1. Better. Let's see what happens when I run the code now. Good news. I have Sherlock Holmes, Clark Kent, and Yoda. Yoda none, but let's ignore the none for now. But I also get an error. Why? Because the fourth time that next was called, doesn't matter, the error here appears above, right? That's irrelevant. The fourth time that next was called, our function, our method, tried to index self.contexts. Index was 0, 1, 2, it's now 3. The fourth item in index, there isn't one. And that's when we get a list index out of range. So we need to do something else. And we can say if self.index is, we could do equal to, right? Because it only happened once, but let's say greater than or equal to the length of context, which is self.context. So for example, in my case, context has 3 items. So index 0, 1, 2 is fine, but the fourth one is going to be index equals 3. And that, we want something to happen. We want to raise an exception. And specifically, we want to raise this one particular exception. You may recall, we've seen it earlier, stop iteration is what the for loop or other ways of iterating, they are expecting the stop iteration. That's the signal to the iteration process, for example, the for loop, to stop. Let's see whether this works. It works. Sherlock Holmes, Clark Kent, and Yoda. I'm going to leave it as Yoda none, but we can put in an extra if statement there. So if last name is none, only return the first name. But I'll leave that for you. Now, before finishing this video, I'm going quite quickly, right? I'm summarizing almost a 2-hour workshop into whatever is going to be a relatively short video. Let me do one more thing first, however. In fact, 2 more things. First of all, let us put some markers here. So let's go back to contact book, which is our iterable. This is where the data is contained, and it's what I want to be able to iterate through. Let's leave a note here using a print statement, calling iter for in contact class, contact book. Why am I doing this? Because then I can see when this thunder method is being called. So let me run the code, and unsurprisingly perhaps, in fact, let's remove that dash, we don't need it. That's a backtick, sorry. Calling iter in contact book. That is happening in line 45. We're converting the contact book my friends, or rather we're creating from my friends an iterator. So that's being called. Okay, let's carry on with this. This will create a contact book iterator object. So whenever we create an instance of an object, its init method is called. So let's put a print there just to see when a new iterator is being formed. Calling init in contact book iterator. So not the contact book, but its iterator. Let's run this. And again, you can see that first we're calling the iter in contact book. This creates the iterator, and that's proof of it. We're creating and therefore initializing the instance of contact book iterator. Let's keep going. Let us show whenever next is being called, calling thunder next in contact book iterator. Let's see what happens now. Now, we're calling iter in the iterable, creating the iterator, and then we're calling next, and this returns Sherlock Holmes. Calling next returns Clark Kent. Calling next returns Yoda, Yoda none. Next is called the 4th time, because we need to call it that one extra time, but this 4th time, it raises a stop iteration. So it doesn't go on to try and fetch the next item. This line would give an error in this case, but the stop iteration comes first. So you can see that next is called 1, 2, 3, 4 times. But the output shows me the 3 items that I have. And to finish off, we've been using this on the for loop, but this iteration happens not just in the for loop, it happens, let me comment that out, in other places we have iteration. For example, we were showing earlier how if I put a star operator for my friends, this only works if my friends is iterable, but we have just made it iterable. So if I run this now, you can see that I get Sherlock Holmes, Clark Kent, and Yoda there. But more importantly, for what I want to demonstrate is that all of those, the same steps that happened with the for loop, have happened here. This is this line, right? So star my friends inside print calls iter in my contact book object. This creates an iterator, which you can see here. It's calling the init function of the iterator. Then it calls next once, twice, 3 times. The 4th time is when the stop iteration is raised, and that stops the iteration. And then prints out Sherlock Holmes, Clark Kent, Yoda. And another example I'll show you in the last one. Let's say we want to sort my friends. Now, sorted is a built-in function, and it needs an iterable as an argument. So this only works if my friends is iterable, which it is, because we've made it iterable, our contact book. So let's see what's going to happen when I try to print sorted. Ready? And there I can see the sorted gives me back a list, right? It gave me a list: Clark Kent, Sherlock Holmes, Yoda. The order is different because sorted in this case was sorted in alphabetical order. So C comes before S, that comes before Y. But more importantly for the topic, that when I pass an iterable to sorted, the same iteration protocol occurs. We're calling iter on contact book, creating an iterator, calling next 1, 2, 3 times, and the 4th time is what raises the stop iteration, stopping the iteration, and then sorted does its magic and returns that. Good. This was super quick. Those of you who are members of the Python coding place, this is discussed in the course Pythonic Loops, which you can find on the platform, on the learning platform. For those of you who attended the workshop, we spent almost 2 hours discussing this. For everyone else, hopefully this video gives you a bit of a taste. Do come and ask me questions. You'll find me on social media or wherever if you read my Substack. And maybe I'll see you in the Python coding place as well if you want to join us there as a member. Hopefully you've enjoyed this whistleblow tour of iteration and what happens when we dig underneath the surface of iteration in Python.